Hello, my name is Dustin. In this video, I want to talk about how radiometric dating works, but more importantly, I want to show two very interesting sources of corroboration for it. Now, the motivation behind the video is personal because I was raised in a fundamentalist Christian religion called the Jehovah's Witnesses, which is something that I left in my mid-20s. In my experience there, I remember feeling threatened by a lot of the claims of science, and I have a lot of memories of watching some science television show and even having it mentioned in passing evolution. It was something that caused a lot of discomfort, the feeling of being threatened. Central to any presentation of some kind of artifact, fossil, or tool of some kind related to the history of humans on the earth is some form of dating or aging the sample or the artifact. And when it comes to this, as a Jehovah's Witness, I would have heard of carbon dating, but of course I was told to see it as basically a false science because it contradicted a lot of things in the Bible, kind of indirectly, because being able to date some tool or some very human-like skull or human skull to something past 6,000 years would contradict the fundamentalist belief that Adam and Eve were created on this earth 6,000 years ago, i.e. the beginning of humans on the earth is only supposed to be 6,000 years ago. Now, besides the catharsis of articulating why my old beliefs are wrong, the purpose of the video is to mend a little bit of a gap that I experienced and see in science media, at least the science media that I've come across, which is that for the most part, when it comes to discussing the ages of artifacts and human remains, it tends to assume that the viewer will accept the findings of radiometric dating. And while this may be the case for the majority of the audience, it is definitely not the case for a fundamentalist Christian watching. So that is, it's not my intention to poke fun at this fundamentalist belief, but instead to show some evidence that illustrates that radiometric dating is corroborated by other things and that it is not a false science. So to start off, I just want to give a little bit of a background of where the belief of humankind's creation taking place around 6,000 years ago comes from. This can be traced back to the Archbishop James Ussher. In 1650, Ussher produced a work entitled The Annals of the Old Testament, and the purpose of this was to pin dates on certain events in the Bible, including the date of creation. Ussher did this among some other methods by chaining up the begats in the first few chapters of Genesis, begats being the language used in the King James Version of the Old Testament. I'll read just a couple of the verses to get the gist of what they are. And Adam lived 130 years and begat Seth. Seth lived 105 years and begat Enos. And Enos lived 90 years and begat Canaan, etc. So, using this method and a number of others, Ussher came up with the result that creation must have taken place in 4004 BCE, or around 6,000 years ago now. Ussher's chronology is still seen as an accurate timeline of the history of the Earth by young Earth creationists, but other religious groups who are not young Earth creationists will still at least see Ussher's chronology as at least describing the history of humans on the Earth, or the creation of Adam and Eve. The Jehovah's Witnesses would fall into this category because they interpret the days of creation in Genesis as figurative days of some arbitrary length, instead of the literal days that Ussher would have interpreted them being. The Seventh-day Adventists would also fall into this category. Side note, the Jehovah's Witnesses and the Seventh-day Adventists are actually cousins of each other, and they both root back to the Millerite movement. They diverged in about the 1850s with an event known as the Great Disappointment, which was when a number of predictions made by a man named William Miller proved to not be true. So they diverged in how they reinterpreted the numbers and the dates that were used by Miller, and they kind of created their own chronology of Bible prophecy. But that's just a little bit of a background of the Jehovah's Witnesses. Now, I just want to say, from certain perspectives, it may be easy to make fun of Ussher's chronology, but it's important to take into account the context of when it was written. And this is something that the famous evolutionary biologist Stephen Jay Gould did. In talking about Ussher's chronology, he said, quote, that it was an honorable effort for its time. That is to say, in the 1650s, science was just not developed enough to provide tools for reasoning about the age of the Earth. And it was only within the centuries following Ussher that science progressed enough to do so, giving us a model for the very tiny in how materials are made up of molecules, how molecules are made up of atoms, and how atoms are of finite kinds, which we call the elements. And technology advanced enough in the 20th century to give us tools to measure on these tiny scales. That is to say that we just have much better tools at our disposal today to peer into the history of the Earth, which leads us to radiometric dating. Now, what are the basics of radiometric dating? That's what I want to answer here. So the key material used to radiometrically date something involves what's called an unstable isotope. So an isotope can be thought of as a certain flavor of an element, specifically one that has a different number of neutrons than the usual element. An example of this is carbon-14, which is an isotope of carbon. Carbon-14 has 8 neutrons, while carbon has only 6. The next piece of this is an unstable isotope. An unstable isotope can decay over time, turning into a different isotope. The rate of decay from one isotope to another is usually expressed in terms of a half-life. And the language used here is that the parent isotope decays into the child isotope. Some examples of these parent-child pairs are rubidium, strontium, potassium, argon, and carbon, nitrogen. The carbon-nitrogen pair being of the famous carbon dating. Now, each of these parent-child pairs have the rate of decay expressed as a half-life, and the half-life of these parent-child pairs are known. Carbon-14's half-life is 5,730 years. There are much longer-lived isotopes. For example, potassium-40's half-life is approximately 1.25 billion years. Now, to go through a very simplified example of how these half-lives are used to date a sample using radiometric dating, let's take the example of a sample having one measurement unit of carbon-14 when it was new. We measure it today and it has a quarter measurement units. That means that the sample must have undergone 2 half-lives, and it therefore must be approximately 11,460 years old. So the takeaway from this is that we need 3 pieces of information to radiometrically date something. How much parent isotope existed in the sample when it was new, how much exists now, and the rate at which the parent isotope decays into the child isotope. Now there's one little piece of information we can get out of this decay graph that we've seen in the example. And you can see that the farther right we go, the smaller the measurement of the parent isotope. At some point, the amount of the parent isotope becomes so small that it can't be measured. In the case of carbon-14, at some point the sample is said to be carbon dead. This is why there's a limitation on carbon dating samples that are past a certain age, and that upper limit is around 60,000 years. But notice this limit is specific to carbon-14. For the longer-lived isotopes, it takes much longer to run into this problem. So the first source I want to cover corroborates radiocarbon dating specifically, which is the shorter-lived isotope. And this source of corroboration comes from what's called Dendrochronology, which is the study of trees and their rings. Now, one way to date a sample of a tree is to use radiocarbon dating because trees are made up of 50% carbon by volume. The other method is dendrochronology, which is to count the rings of the tree. Because you may know, trees create annual rings, each one deposited about the circumference of the tree. If you see a tree still living today and it has 80 rings, you can be sure that it is at least around 80 years old. Now, trees only live for so long, so any individual tree only allows us to reach back so far in time. The strength of dendrochronology comes from chaining multiple trees together, and this can be done by pattern matching the thicknesses of the tree rings between 2 trees that have lived in the same region. Now, the width of a tree ring depends on the amount of rainfall that it gets during the year. So if 2 trees lived in the same region and in an overlapping period of time, that means they should experience the same pattern of droughts and the same pattern of rainfall. The trees that can make up the links in this chain can be taken from trees that are still living, support logs in historical buildings, and trees that have fallen into bogs. Now there is one particular chain of trees that's called the bristlecone pine chronology. And this chain allows us to reach back 10,000 years in this contiguous chain of tree rings. The important part of this is that at every point in this chain, we can compare the carbon-14 age with the tree ring age. So this ends up being a very strong source of corroboration for radiocarbon dating. One really interesting thing is that dendrochronology not only is a source of corroboration for carbon dating, but it's actually used as a source of calibration. What that means can be illustrated by this graph. The vertical axis, the y-axis, represents the carbon dating age, and the x-axis, or the horizontal axis, represents the absolute age, the actual age. And so what you'll notice is that there is a 1-to-1 line on a 45-degree angle in the center of the graph. So if the data fell along that line, that would mean carbon-14 age lines up perfectly with the actual age. What you'll notice is that it doesn't. It's consistently below that line. That means that carbon dating actually undershoots the actual age of a particular sample. So without this source of corroboration, carbon-14 results would actually be too young, and calibration is needed to kind of bridge that small gap. I won't go into too much detail about what the cause of this difference is, but the gist of it is that the source of this error can come from the fact that the amount of carbon-14 in the atmosphere has varied over time, and dendrochronology is a source of knowing what that variation has been and allows us to adjust the carbon-14 dates. So dendrochronology is a very strong source of corroboration for carbon dating specifically. The last source of corroboration has to do with the longer-lived isotopes, the ones that are usually used to, for instance, age fossils. Now, one side note is that fossils aren't directly radiometrically dated because fossils don't tend to contain unstable isotopes. Instead, igneous rock layers do. So an igneous rock would be one that was at some point molten and then crystallized, and in the strata, in the column of strata in a region that contains fossils, the fossil strata will generally be sandwiched in between igneous rock layers. There will be a lower and upper igneous rock layer. Now, this means that the fossil layer must be younger than the below igneous rock and older than the above. So in this way, fossils are bracketed between igneous rock layers, which can be radiometrically dated, which I think is pretty cool. It's pretty cool. It's pretty cool. Now, this source of corroboration involves ancient fossilized corals from the Devonian period of Earth, which is also known as the Age of Fish. This source of corroboration and the story itself is relayed in Jerry A. Coyne's book, Why Evolution is True, which I happen to have right here. These fossilized coral were studied by the paleontologist John Wells in the 1960s, and these corals became among the first paleontological evidence for the Earth's rotation decelerating over time. How could fossilized coral lead to something like this? Because it seems so unrelated. Coral are special in that they have annual growth lines, something like a tree. But what Wells noticed was that there were these intermediate growth lines between the annual growth lines of the coral. He looked at modern coral and counted some of these intermediate growth lines. And what he came up with was a number around 365, which is the number of days in a year currently. When he counted these same lines in the fossilized coral, he counted something around 400. What this implies is that when these ancient corals were alive, they experienced around 400 days in a year. Now, since the time it takes for the Earth to orbit the Sun is more or less constant, that means the number of hours in a year is constant too. So we can determine the number of hours that these ancient fossilized coral must have experienced in a day by doing the simple division, the number of hours in a year divided by 400. What this comes out to is 21.9 hours. That means when these ancient coral were alive, they must have experienced something around 21.9 hours in a day. Their days were shorter than ours are today. Now, this is where the corroboration comes in. They're an independent way of reasoning, come up with how many hours these coral must have experienced without the growth lines of the coral by combining two pieces of information. One is the radiometric age of these coral, which was approximately 380 million years. The second piece of information is an approximation of how quickly the days on Earth are lengthening. That is, the deceleration of Earth's rotation. One approximation, and one that Coyne uses in his book, is that approximately every century, every 100 years, the amount of time in a day increases by 1.9 milliseconds. How we'll combine these two pieces of information to get the number of hours in a day experienced by the ancient coral, I'll show via an animation. Now in this plot, the x-axis represents millions of years, both in the past and into the future. So the left-hand side represents millions of years into the past, and the right-hand side millions of years into the future. And the vertical axis, or the y-axis, represents the number of hours in a day. So if we assumed that the length of a day didn't change over time, then we'd get this horizontal line at 24 hours. But if we plot the deceleration of Earth's rotation, that plot tilts like this. And now we use the radiometric dating of the fossilized coral, which was 380 million years. So we start at the middle at 0 on the x-axis, and we travel 380 million years to the left into the past, and we see how many hours that gives us in a day. What that gives us is around 22 hours in a day. Now we can compare that with the number of hours in a day we gathered by counting the rings of the fossilized coral, which was 21.9. See, that's just a difference of 0.1 hours. Quite a close agreement. So in this way, the growth lines of the ancient coral corroborate the radiometric age of the corals. To conclude, I just want to present 3 examples of evidence that illustrates just how much history there is of humans on this earth beyond 6,000 years. The first is a cave bear flute, a flute carved from the femur of a long extinct species of bear, one that went extinct around 24,000 years ago. Now this was found in Slovenia, and it dates to around 60,000 years ago, an order of 10 from 6,000 years. Another example is another flute, and it's an ivory mammoth flute, one carved from the tusk of a mammoth. This was found in Germany and dates back to 30,000 years ago. The last example I want to go over is, of which there are many similar to this, but there are cave paintings in the Chauvet caves in southern France. These date to upwards of 30,000 years. Now this cave and its paintings is the subject of a Werner Herzog documentary called The Cave of Forgotten Dreams, and I would really recommend seeing it. It's something to be able to look into these caves and see what was of interest, what was painted on these walls 30,000 years ago. Now the union of these and countless other findings with the help of radiometric dating tells a coherent story, tells of human migrations over the past 100,000 years, how 60,000 years ago humans fanned out from Africa, and how their migrations coincided with changes in Earth's glaciation. And to ignore such a coherent body of evidence and assert that humans began around 4004 BCE with Adam and Eve in the Garden of Eden, and that their migrations were motivated by original sin and the spinning sword, constitutes a fleeing from reality. I hope I've been able to make some of the details of radiometric dating and some of its corroborations more accessible, and I hope it was interesting. So thank you for watching.